All right, welcome back to the lesson for the day. Okay, we will continue from the discharge action at a point. The discharge action at a point. Now, from our last lesson, we already know that in a conductor, the, the charge density is concentrated at the sharpest point of the conductor. So it means that charges concentrate on the sharpest point of the conductor. However, if this conductor that has a sharp point is placed in the air, now it causes the what? The surrounding air around it to be what? To be neutralized. It causes the surrounding air around it to be what? To be neutralized. And by neutralizing them means what? Breaking them into what? Positive and negative what? Ions. So what we mean is, if for instance, this is the sharpest point of the conductor, let's assume this sharpest point is what? Is positively charged, and it is placed or suspended in what? In air. So what we are saying is what? It will cause the surrounding air closer to the sharpest point to be what? Neutralized. That means by breaking them into what? Positive and the negative what? Ions. So by breaking them into the positive and negative what? Ions, after breaking them into the positive and negative ions, it will tend to what? Attract all the negative what? Ions. Why is it attracting the negative ions? Because the point is what? Positively charged, for instance. If the point is positively charged, it neutralizes the what? The surrounding air, breaking them into what? Positive and negative ions. And then it will tend to what? Attract all the what? The negative what? Ions. It will tend to attract all the negative ions and strongly what? Repel the what? The positive what? Ions. So this is what it does. Neutralizes the air, attract all the negative ions, and then repel all the what? The positive ions with a fast what? A greater what? Speed. So these positive ions that are what? Are being repelled by this what? This positively charged what? Conductor will be moving off very, very what? Fast. So as they move very fast, they will collide with other what? Air molecules around. So when they collide with other molecules around, they will also strip off electrons from them. By stripping of electrons from them, it causes what? Further what? Ionization. So it will cause the surrounding air to what? To keep what? Ionizing. And the conductor keeps attracting all the negative what? Ions and keep repelling all the what? The negative what? The positive what? Ions. So that is how the process what? Continues. So within just a short period of time, this surrounding air or these ions that are actually moving very fast will have a what? A cumulative what? Effect. And this cumulative effect will what? Will cause the surrounding air around the what? The conductor to be what? To be dragged along with it. And when it drags along with it, it causes what is known as the what? The electric what? Wind. So that is what will happen when this highly charged pointed what? End of a conductor is what? Is placed in the air. All right. So that is what actually what takes place. So the whole action or everything we are talking about here is known as the what? The point action. We call this the what? The point action or the what? Discharge action at a point. So that is what happens anytime we have a what? A highly charged what? Conductor that is placed in a what? In air. It causes the what? The neutralization of the air. So the next thing we will be looking at are the lightning and lightning conductors. Lightning and lightning conductors. All right, so let's start from the normal and simple experiences we have. Now, you will notice that in a dry day, especially during the summertime, when you wear your sweater and you're in a dark room and you're trying to pull the sweater off, you notice that there is what? This kind of strong attraction between the what? The sweater and your what? Your body. And when you try to pull it, you begin to hear some what? Some crackling sound. And in some cases, you begin to what? To see some little what? Light. I want to believe you can attest to that. So all these are actually what? Lightning and what? and thunderstorm that is actually taking place, but you know what, in a small scale, but you know what, in a small scale. So lightning and lightning conductor, or let's talk about lightning first before we go to lightning conductor. So lightning and thunderstorm, they are actually what, in a small scale. It actually occurs when a what, a negatively charged what, cloud is discharged rapidly by a what, a positively what, charged cloud, which causes the what, the thunderstorm. So once there is that attraction, that is what causes the what, the thunderstorm. All right, so let's go to what we have generally in our environment. So when we talk about lightning, and we'll talk about what? Lightning in the world, the atmosphere. So what happens when we see lightning, and immediately after the lightning we hear what? A very roaring sound of the word, the thunderstorm, and which causes what? Some destruction to the properties. Okay, so what happens is when electrical or charges build up in the what? In the thundercloud. So once these charges will build up in the what? In the thundercloud, there will always be a what? The attraction between what? The charges within a particular cloud keeps what? Increasing. The attraction between the charges within a particular cloud keeps what? Increasing until a positive what? A charge, a positive charge from a cloud jumps from what? Its own cloud towards another what? Cloud to discharge it rapidly. So once that is done, now that is when a large spark will be what? Will be seen, telling us that what? That a negatively charged cloud has been discharged by what? A positively charged cloud. And this what? Takes place either from one cloud to another cloud, or even from one cloud down to the what? The earth. This discharge actually what? Takes place. So once that is done, we often see what? There will be a large what? Electrical discharge. So by this electrical what? Discharge, that is what we call or we see as what? Lightning. So that is what actually what? Takes place. So once this takes place, now a large amount of what? Of energy, of heat energy is what? Is released once this electrical discharge takes place. And this electrical energy, or this heat energy that is what? Discharged, or that is released due to this what? Discharge, can cause what? Damages to what? To a tree or a building or any tall structure in the what? In the earth, if a safe path for this what? Energy is not what? Provided. So therefore, that energy that is released due to that what? That discharge that is taking place in the what? The cloud. If any safe path for this energy to what? To come and flow is not provided, if it fall on any material that offers the least resistance to it, then it will what? Collapse or destroy that what? Structure. So a lightning conductor by its nature is what? A device that is specifically designed or made in order to prevent what? Buildings or tall structures from what? From thunderstorm. So that is a function of the what? The lightning conductor. So its function is what? It will help buildings what? Prevent buildings from what? From the destruction of what? These large or enormous amount of what? Energy that is what? Released during what? Thunderstorm. So the next question is, how does this lightning conductor looks like? And how does it what? Work? So let's look at a diagram of the what? The lightning conductor, and let's see how it actually works to prevent our buildings and our structures from what? The destruction of the energy that is released during the what? The um, electrical discharge. All right, so this is the what? The lightning conductor. The lightning conductor. So we already said the use of the lightning conductor is a device that is specially made in order to what? To prevent buildings or tall structures from what? From the destruction or the damage of what? Thunder storm. That is the energy released in what? In the thunderstorm. All right, so a lightning conductor consists of basically a what? A very sharp what? Of point metal, which we call the spikes. This is the sharpest point of the what? The um the lightning conductor, and that point is always called the what? Is often made to be very, very sharp, so that what? The charges that will be concentrated there will be what? Very, very what? High. And this lightning conductor is most times found at the what? The tallest part of a what? Of a building. When you check buildings, check the top of the building, there will always be a what? A very sharp what? Conductor that is placed at the what? The tallest part of that what? Building. So that is where the lightning conductor is most times what? Located in buildings, in order to stop the what? The thunderstorm from what? Striking the building. So that is where the lightning conductor is found in buildings. So we say that it has a what? A very pointed end, and we say it's actually pointed so that what? The charge density there will be very, very high, and is normally made of copper, and we also have what? That sharp point is connected to a what? A thick copper what? Cable. The sharp point is connected to thick copper what? Cable. And the thick copper cable is connected to what? A copper plate that is buried on the what? On the ground near the what? The building. So from that what? Sharpest point, we have the thick copper cable that is connected to what? A copper plate that is most times buried what? Near the ground. So how does the lightning conductor actually works in order to prevent the building from what? From damage. All right, so what happens is when a negatively charged cloud, for instance, actually passes closer to the what? The top of the building, that is closer to the what? The lightning conductor. So when, for instance, a negatively charged what? Cloud, this is a negatively charged cloud that passes closer to the what? The top of the building. So because this cloud is negatively charged, it will induce a what? Positive charges on the what? The metal what? Spikes, or the sharpest point, because right from the onset, that sharpest point does not have any charge. It's what? Is neutral. So the charge that will be induced in it is depending on the what? The type of cloud that passes closer to it. If it is a positive cloud that passes closer to it, then that positive cloud will induce a what? A negative charges on the what? The metal spikes. But and if the cloud is what? Negatively charged, that cloud will induce the what? A positive charge on the what? The metal what? Spike. So what we are saying is, for instance, when a what? A negatively charged cloud, this is a negatively charged cloud, passes closer to the what? The top of the what? The building. So that negatively charged cloud will induce a what? A positive charges on the what? The metal what? Spikes. So when you induce what? This positive what? Charges on the metal spikes. And of course, we know that the metal spark is what? Is a sharp point, meaning that the charge density there is what? Is very high. So what will now happen? So that point will begin to what? To ionize or neutralize the what? The surrounding air that is closer to it, because it's a sharp point, and it works on the what? The point action, or the discharge action at a point. Since the point is what? Is sharp, and positive charges have been induced in it, it will begin to what? To neutralize the what? The surrounding air closer to it. So by neutralizing the surrounding air, it begins to break them off into what? Positive and negative ions. So by breaking them into the positive and negative ions, it will begin to what? Attract all the what? The negative ions, and repel off all the what? The positive ions. So these positive ions that are repelled by this what? This sharp point, where will they now move to? Because they are repelled, they will move off and go to the what? The upper part of the what? The atmosphere. These positive ions that are repelled at this point will move up to what? To accumulate at the what? The upper part of the what? The atmosphere. So when they accumulate, they will now form a what? A positive charge what? Space high up in the what? In the atmosphere. So when they form a positive high space high up in the what? The atmosphere. Now they will begin to what? To discharge this what? Negative what? Charge cloud. Those positive ions that accumulate begin to what? Discharge the what? The negative what? Charge cloud. So when they are discharging the what? The negative charge cloud, they will begin to reduce the possibility of what? Of lightning from what? Striking the what? The building, because the negative charge cloud is already what? Discharged. So by discharging it, however, if some electrons that are what? From the negative charge cloud were not discharged by this what? Positive charge space, Those electrons, if however they were able to still strike the what? The highly what? Pointed, sharp pointed end of the what? The lightning conductor. Now, those electrons will be what? Will be conducted harmlessly through the what? The copper what? Cable down to the what? The copper plate that is buried near the what? The building. So without actually what? Destroying the building. So those electrons will actually move or flow from that point down to the what? The earth. Although they will not be what? Be much, because most of the what? The negatively charged class have already been what? Been discharged by the what? The positive high space that is what? Build up high up in the atmosphere. So generally, this is how a what? A lightning conductor actually works in order to prevent a building from what? Destruction. All right, so the last thing we shall be looking at as far as electric charges is concerned is the what? The storage of charges. The storage of charges. Now, basically, we have 4 devices that are used for storing or for transferring what? Electric charges. And these devices, we call them the what? Electrophorus. We also have a capacitor. We have the Leyden jar. And we have the Van de Graaff generator. All right, so basically these are the 4 devices that are used for storing or transferring of what? The electric charges. The electrophorus is a device used for transferring and storing of what? Electric charges. It is just made of a copper and an insulating stand. So by placing the what? The material on the charge device, it will be able to what? To absorb some charges on what? From the device. And when it is placed in another body, those charges it has what? Absorbed, it will transfer it to that what? Other body. Or if it is not placed in any other specimen, it will still remain in the body. So it will store the what? The charge that it has absorbed from a particular body. So that is how the electrophorus works. Then we also have the what? The capacitor, which is a business for another day. We'll look at the capacitor and how does it actually work to store charges. We also have the what? The Leyden jar and the Van de Graaff generator. So all these are the what? The different methods of what? Or devices of what? Storing of electric charges. So by this, we've come to the end of the topic. So you what? Stay tuned for the next video on the next topic. Have a nice day.